So we're going to look at decision making under uncertainty. Tomorrow or the next session, that's when we'll look at decision making under certainty. So a decision problem where a decision maker is aware of various possible states of nature, but has insufficient information to assign on the probabilities, we term this as decision making under uncertainty. You don't know the chances that you're going to make a certain profit. You don't know what associated probabilities are attached to that. So that is called decision making under uncertainty. But a decision under certainty is where the probabilities are known. You would be given specific states of nature, and states of nature in this case are a state in which um, an economy may be. We have several states of nature. It could be a boom, a recession, a depression. You'd be given specific states of nature. Usually, for exam purposes, they'll just want to generalize them as S1, S2, S3. But for this, I would want to give you the methods of decision making under the following. Number one, we will discuss the method of decision making using what is called a maximax. Under a maximax method, here we are simply picking the maximum values under the maximum alternatives. So there'll be alternatives where you pick maximum values in each state of nature or in each alternative, then you pick amongst the maximum the highest value. That is called the maximax. The max mean is where we maximize the minimum value of the alternatives. So amongst the minimum values on the available alternatives, you pick the highest, which are the maximum. So from the terms you see, it will make more sense as we go through the questions themselves. We also have what we call a regret criterion or a minimax, where we're simply minimizing the maximum value of the alternatives. We pick the smallest amongst the maximum values. So we'll be using what we call a regret table. I'll refer this to your assignments and your tests, and we'll see how and what much of this means. There's also what we call a Laplace. This is a method under decision making where we simply get the average firstly, and from the average, we choose the maximum values of the average. Then we have what we call the Hewigs. This is a method where we use an alpha value, which is often given, to the largest value, and the beta, which is the difference from the alpha on the smallest value. Now, whatever I have just mentioned now, I'll give you an example where a decision maker has three possible alternatives. We have alternative 1, A1, A2, and A3, where the outcome of each of them can be affected by the occurrence of any one of the four states of nature. We have S1, S2, S3, and S4. And we've been given what we call a monetary payoff for each combination. We have A's and S's, which are given as follows. So we have A1, A2, and A3. We have S1, S2, S3, and S4. Now we want to use what we call maximax value. So now, please, without any prior information, get it from me. If you're given such a payoff in each alternative here, let's identify the highest number. Our highest number here is what? 27. So this is a 27 here. And in this very row, what is the minimum number? The smallest number here is what? 12. So we put the minimum value there. We do the same here. Alternative number 2, we need to identify what is our highest number. We have 45. And what is our smallest number? We have 17. Then we go to alternative number 3. Identify the highest number here. Our highest number here is, what is our highest number in this column? What is our highest value in here? We have 52, and the smallest is 15. So we are now required to make a decision for each alternative using a max-max and mini-max. Now let me start with these two because they're the easiest. What did we say was a max-max? We are told that we need to identify amongst these values on the maximum values, which one is the highest? Amongst the maximum values, which one is the highest? 52. So 52 is a maximum value amongst the maximums that we have. So our max is alternative number 3, which gives us a payoff of what? 52. So this is the criteria we're going to use. So for a maximum, we select or invest in alternative number 3, which has the highest value of 52. Then using the second criteria, which is called the max min. So we go to the minimum values and we look at the maximum value amongst the minimum. But to know which one is big, which one is our maximum value? 17. So using this criteria, we're going to select alternative number 2, which has a max min. Okay, the maximum amongst the minimum values, which is 17. So this is our second method under decision making, which we pick. So this is 17. Then when we go to the regret table, we identify the highest number in each column and we subtract it. So here our highest number is what? 52. Here our highest number is what? 36. Here our highest number is what? 35. And here our highest number is what? 26. So using the regret table, we pick the highest numbers and we subtract from each of the values here. So 52 minus 52, here we're going to get a 0. 52 minus 45, we're going to get a what? A 7. 52 minus 27, we're going to come up with a table here where we're subtracting the highest values from each of them, the highest values from each of them, the highest values from each of them. This is what will lead us to now identifying the maximum values from each of these columns. Like we're finding a max from the regret table. So our highest value here is 25. Our highest value here is 19, and our highest value here is 11. But of these ones, we are picking the smallest of them all. So this value is 11. The value we're picking is 11, and this is what we call our regret. Before I move any further, let's do a can you remember? Quickly, how did we get our max? Can somebody remember what did we do first? Chungu, Cornelius, Chipa, what did we do first? How did we get these figures here? 27, 45, and 52.
You got under each alternative A1, A2, A3. You got the maximum values under each state of nature. And you got the minimum values. So under max, you got the maximum, which is 52. That's the highest.
Okay, so this is using what criterion? The max, yes?
Yeah.
Then under the max mean.
Under the max mean, we at the minimum values, then you got the maximum of the minimum values.
Good. We got the maximum amongst the minimum values. All right. That is under the maximum. Then we went to the regret. Under the regret, what did we do? Anyone else to take it on? Using the regret table, what did we do? Chiwoni? Cornelia? What did we do? Say something. Yeah. Although you're faint. Much better.
Under each state of nature, we get value, and then we subtract each of those values boxes under alternative 1, 2, 3, and then when we're done doing that, we get the minimum value under each alternative. Then to make a decision, we get the least of the smallest value.
Okay. Exactly. Thank you for that. So what she's saying is we identified the highest values in each test of nature. Then we subtracted the highest value from each of the values. This is what we call the regret table. Then in each of the rows, we identify the maximum values. And from the maximum, we pick the lowest values. So this is how we found this table. Okay, it's a regret table. Then we pick the lowest value, which is alternative number 3. Then we go to what is called the Laplace. According to the definition, the Laplace is simply the average. So the average for alternative 1, we add all the payoffs 27, 12, 14, and 26. We divide by 4 since there are 4 in there. 27, 12, 14, then we divide by 4. So we're getting the average for each of them. Alternative number 2, we add all of them and divide by 4. Alternative number 3, we add all of them, divide by 4. And from them, we look at the highest value. Which one has the highest value in this case? 33. So 33 gives us the highest value, and we pick alternative number 3, which has the highest value. So this is what we call the Laplace. Laplace method under decision making is one where we pick the average values. Then we have what we call the Hewitt. The Hewitt, we're given what we call our alpha. The alpha is often given. Then the beta should be the difference from the alpha, which is 0.3. So if 0.7 has been given, 0.3 must go to the minimum value from our max. Okay. So in this column here, the original question, we have our highest value here being 27. So we are putting 0.7 on the highest values. Okay. So the smallest value here is 12, 17, and 15. So we're going to put 12 against 0.3, 17 against 0.3, and 15 against 0.3. So we're just using the maximum value and the minimum values using the alpha and the beta. So when we put each one of these ones, we then select the highest payoff. So in this case here, the 0.7 against the 27, the 12, this is 12, not 10, against 0.3. So in this, our highest is what? A3. So A3 is the one that gives us 40.9. So you pick the highest value. Okay, so before I go to the decision, decisions under uncertainty, I'd want us to quickly, yes?
Please just go through the one you've just done. The network is quite bad, so I couldn't hear you for a bit.
Okay. So let me go through what I've just done now. So to use the Hewick, we will always be given an alpha value, 0.7, meaning it's like P and Q. If alpha is 0.7, the beta is 0.3. So what you do is you go to the maximum values and the minimum values that we found here. So here you're going to put 0.7. And here we're going to put 0.3. So we're going to multiply 0.7 times 27 plus 0.3 times 12 equals. Then we go to 0.7 times 45 times plus 0.3 times 17 equals. Then finally 0.7 times 52 plus 0.3 times 15 equals. Then from there, you pick the highest value that you find. That is the method called the Hewick. The Hewick uses the alpha value to the largest value and the difference, which is the beta, to the smallest value. Okay, so if we're going to go to one of our tests we did, okay, this one here. If you're a decision maker with the conditions under uncertainty, how would you decide using a Laplace, using a max-min, and using a max-max? Okay, so let's go. How do we find the two easiest ones? Actually, this was a very easy question. How do we find the max-min and the max-max? Let's participate. Chungu, cheaper. What do we do? This is question number 9, 10. So the first thing is, you want to say something?
Yeah, which one are we starting with, max-min?
Yes.
Oh.
Okay, you can choose 1, 2, 3. Yeah, choose any because I've explained all of them.
Yeah, the first one is easy. The first one is in the Laplace. You go in under the decision alternative. You had 7 plus 6 plus 9 plus 11 plus 10 plus 12 divided by 6.
Okay, you add all of them in short.
Yeah.
Then you
Then we divide by 6.
Excellent. You divide by 6. There are 6 of them. You get the average of each of them. Okay, D1, D2 up to D6. Then what criteria do you use?
You get the highest.
The highest of them. That is what we call a Laplace. Next, somebody else? Max-min and max-max. Was there only one person listening? How do we use the max min and the max max? Okay, you can help them. I think you're the only one who was in class. Help them. So we pick in each of the alternatives.
I'll just try in each of the alternatives, you pick the maximum.
Here we have what?
There we have 12 as maximum.
Okay, so question 10. Okay, so the Laplace is explained. We add and we get the average of each one of them, and we pick the Laplace. The highest value here is D6, which is 9.67. Okay, then for the other ones, we have the payoff table. We pick the minimum value and the maximum value. So when you go here, the smallest value is 6. When you go here, the highest value is 12. Here it's 6, the smallest value, and the highest value is 12. Here, the smallest value is 6, the highest value is 12 again. Here, the smallest value is 6, the highest value is 14, etc. until the end. So, question, how do we use the max max and the max min? How do we find the max max and the max min?
The max is under D4 where we have 14. And the max min is under D6 where we have 8.
Okay. Are we agreeing? So the max max, we find the maximum value in the maximum column. So the max max is what? 14. The max min, in the minimum column, you pick the highest value, which is D6. So max min is D6, okay, with the maximum value of 8. Okay, the max max, we get the maximum value with the highest value of what? 14. Then how do we find the regret table? We later on have been asked to find the Savage criterion. How do you use the Savage criterion? Using the regret table, what do we do? In each column, you identify the what? The highest value. In this column, what's the highest value? 12. Here, what's the highest value? 14. Here, what is our highest value? 12. Here, our highest value is 11. Here, 11. Here, 13. When you find the highest value, what do you do? When you find the highest value, what do you do?
You subtract the numbers under each state from 12.
Good.
The column.
So in here, we're going to subtract each element minus 12. Here, each element 14 minus each element in this column. So this leads us to where there was 14. Okay, there'll be a 0, there'll be 1 0 somewhere or more than. So we're subtracting the highest value minus all the figures in there. After we do so, we identify the highest values in each of these what? Rows. What is the highest value here? 8. What is the highest value here? 7. Value here? 6. Highest value in here? What's the highest value here? 5. Okay. What's the highest value here? 8. What's the highest value in here? 5. So after you do this, what next? What do you do? After identifying the highest value, how do we use the Savage criterion to identify which alternative to pick?
You get the minimum. So we have two D4 and D6.
Good. So you pick the minimum, D4 and D6. So using the min max, it means we are minimizing the maximum value of the alternatives. So D4 and D6 are our sources that we are going to use to make our decisions. Mind you, we don't have any probabilities here, so we're discussing making decision using uncertainty. So these are the methods that we use for decision making and uncertainty. There are 5. Max max, max min, regret criterion, which is a min max, then the Laplace, and finally the Hewitt. So since today is the introductory class, I'll end here, and tomorrow we'll look at using certainty.